Hello and welcome back to Shapes.io Alpha. Today what I have here for you is a 7x9 fully programmable grid display. Now I'll start off by showing you how it works, and then next I'll go over some of the more technical stuff, showing you the different components and the process I took to make it. So as you can see, right now it's displaying the letter A, but this can display anything in a 7x9 area with any color. So right now I'll just let this run. Over here I have a binary selector panel. So the way this works is you enter in a binary input, and then that will decode it into a symbol. So let's say we enter in the binary number 3, right? So that's these two. That's a D, right? Because if 0 is A, then 1, 2, and 3, that will be D. And this button, well, this button is just I've made this clock. It's a T flip-flop clock. And the reason this is so long is because I've actually increased the tick rate, so this all works faster, because each gate takes 1 tick to work. So if I increase the tick rate, it means that this entire system will work faster, but I also need to increase the clock size. So I'll just let the clock run in the background as I explain this. So this entire grid runs off of shape decoding. So the way shape decoding works is that you have a shape, right? And that has 4 layers, and meaning 16 corners. And each of these corners can be read by an analyzer. So if the corner is, if it is uncolored, that means it won't display anything, right? But if it's colored, then it will display. So the way this works is it takes 4 shape inputs, it unstacks them, and then it goes through them, analyzing each corner. And each of the corners is a lamp, which lights up. So the hardest part about this was actually programming the stuff in. So you can imagine how you have to figure this out, like work it out, like, well, what each corner corresponds to each display. So if we go up here, we can see we have this entire decoding circuit. Yeah, it's pretty big. Right now I have like all the symbols on your keyboard and plus a few extra. So as you can see, right now it's on the colon, the apostrophes, and stuff like that. Equals, plus, brackets. So the way this works is only one of these, this is a binary decoder, and only one of these will be lit at a time using because each one of these rows has a different configuration of binary inputs. So that will light up only one of these rows, and when a row gets lit up, it outputs 4 shapes. And these 4 shapes are able to control the entire display, so it's actually gone through everything. And I actually haven't, since this can actually have 128 different outputs, but I haven't actually programmed 128. But since there's 7 bits, yeah, so right now it's just looped back, and now it's at the capital letters again. So next, what I've made is I've chained them. And now we can display words. So right now, I'll go over this slowly. So it's WELCOME, welcome, right? Next, if we click this, it says 2. Click it again. Whoops. And Shapes.io. Yeah, it says, welcome to Shapes.io. So what I've done is taken the different codes and just programmed them in. And I have this little binary decoder. I also have this T flip-flop chain, which is similar, or it's the same to the one over here, but this one's just longer. So now this will get a bit more technical, as I'll start by showing you how each different component works and with more detail. So let's start off with the inputs. First we have this manual binary input, and then we have the clock enabler. So first for the clock enabler, this will either enable the clock circuit by, as you can see, this will enable the clock outputs over here by turning these gates on, and if this is off, then the manual binary will be on. And also this enables this NOT gate chain, which is a clock. The way this works is that when this is on, it allows this NOT gate chain to pass an input through, and then once it passes fully through, it will then turn off, and then it will chain through, and then it will turn on. It just alternates. And then we have a 1-tick pulse. So for this T flip-flop design, you actually need a 1-tick pulse for it to work. So the way this works is that this will go into the AND gate, this will turn on, and then a single tick later, this NOT gate will turn off, turning this AND gate off, meaning only a pulse of 1 tick will go through. And this is a T flip-flop design, where each of these XOR gates loop on each other, right? But if it receives a second pulse, this will cancel out because it has 2 inputs, meaning it'll turn off. So as you can see, if I turn this off, or if I turn it on, the things will alternate. And this is actually counting in binary, if you watch closely. So that's the way the clock works. And then for the manual inputs, well, you just manually input the binary over here. And then these 2 lines link up. Next, for the binary decoding. So the way this works is that you have each of these lines, which represents 1 digit in the binary number, 1 bit. So each of these lines, they go all the way through the decoder. As you can see, nothing interrupts it. It goes all the way up, meaning there's no ticks of delay between each thing. Well, obviously there will be ticks for the decoding, but this line will be passed up instantly. Now the way this works is that each of these rows has a combination of AND gates and this 7th line, which is a NOT gate, or just a normal gate. And how this works is that one row will only turn on at a time. If, let's say, the first row, which is 0, meaning all of these have to be off, so that means we have to NOT all of these. And if these are all NOT, then this will turn on. For the next one, since these are not all knotted, there's actually conflict here, because this gate passes a 0. So we just keep on repeating that. So you can see now it's the first one that needs to be on, then the second, then both the first and the second, and that's the number 3, and then for 4, it's the 3rd bit, and then you keep on redoing that, and you keep on counting in binary all the way up to 128, yes. Right now I have something like 104 programmed in, I think. Where I have the capital letters, it's the first 26, then the lowercase letters, then the numbers, and then a bunch of symbols. So, next for the shape decoding. This, I'll show you how I decoded everything later. But I already explained this, so I'll go into a bit more detail. So each shape has 16 different corners, and these corners can be any color, any of the 7 colors, or uncolored. And that lets us control each pixel so we unstack it, and then we analyze the corner, we rotate the shape, analyze the second one, rotate it, and do that. So right now there are actually 63 lamps. Technically I could do like an 8x8 and that'd be 64. But since it's just a letter display, a 7x9 is much better. So yeah, as you can see, this is not too complicated. It seems a bit complicated, but if you go through it, it's quite simple. You unstack the shape, top layer goes in, and the rest of the 3 go to the next unstacker, unstack it, analyze it, and then you unstack it a 3rd time, and the 4th input goes down here. So yeah, the input order is a bit strange, but I'll show you how all this works, or how I decoded it all after. So next, for the chained displays. So first, the input. First we start off with a 1-tick pulse, and we have this T flip-flop chain again. There's only 2 of them because there's only 3 different words, and then there's 1 empty word, which I don't have. You can see the empty word has only empty shapes. So if you want to add a space, that just means you add 4 of the empty shapes. So this is also very simple. You just decode the binary, and then you have these 4 shape inputs, which input into the display. And you can write any of the letters, any letter or any symbol that I have programmed in. Shapes.io. So next for the shape encoding. So as you can see, this is not easy to understand, like the order of stuff. It's very complicated. So what I've done is made a spreadsheet. Also, another issue is that there's no counterclockwise rotator. So when you're decoding a shape, first it starts off with the top right corner, right? But then when you rotate it, it goes to the top left. So when you're doing, because shape code is top right, so top right, then it's top or bottom right, bottom left, top right. But when you rotate clockwise, it goes top right and then top left, and then bottom left and bottom right. So everything is backwards, meaning decoding this was kind of a mess. So I really wished I had the counterclockwise rotators, but right now there aren't any. So that's kind of annoying. But I found a way to deal with that. So to decode it, I made a spreadsheet which has all the shape codes, and I'll show you right now. So here's my spreadsheet. So if I zoom out a bit, you can see that it's quite big. And yeah, here I've grouped up the capital letters, lowercase, and numbers and stuff. So yeah, so it's 4 shapes per symbol, 4 shapes, and these are all encoded. So this seems like a lot of work, but 90% of was automated thanks to 2 people, Alex X and Emerald Block. They both helped me speed this up a lot. So first, let's start off with, this left side. As you can see, we have this grid. This is a 7x9 grid, so you might understand what's happening. So this is the order of the shapes, or the order of each corner input. So we start off with 1. So if we look at the actual thing, you see we have the first shape. It goes in through here, unstacks, unstacks, unstacks. And right now this line's the bottom layer, right? So the bottom layer is going into here, and this is 1 right here. The first one. This is the top right corner of the bottom layer of the first shape. So what I've done is I numbered each of the pixels off in the correct order. So 1 is the bottom right, and then 2 is 1's the top right, then 2 is the bottom right, and then 3 is the bottom left, 4 is the top left, and then 5 is the next layer. So that's quite simple. So for the actual encoding, I have these numbers, and each number represents a pixel on the display. And these numbers they can be in any order, but I prefer them to have from left to right and then top to bottom. So this is the only, this started off manually. As you can see, this is for the letter A. So each of these pixels will make up the letter A. And this all started off manually, but then Emerald Block came along, and he said he could help me automate this too. But first, we'll talk about the formulas which I've used. So Alex X, he was the one who gave me the formulas. So as you can see, each of these tiles has a formula up here. So what this does is it searches for a certain number, and if that number is there in the code, it will mean that that position will be lit up, meaning it goes the shape code becomes RU for rectangle and red. Else, if it can't find that, it'll be RR, and then this, if it can't find it, it'll be RU, meaning uncolored. So what this does, it searches from the numbers 1 to 63, and it encodes it into the either RU or RR for each shape, and then over here, each of these, as you can see, you see we have layer 1, 2, and 3, and 4. So let's say the first shape, it concatenates them. So there's this concatenate function, which Alex showed me. And you see it concatenates the first 4 corners, the second, third, and fourth. And that's for the first shape. And then the second shape is over here, third, and it does that 4 times. And then you can, if you want to expand this, it's quite easy. You can just select these, and then if you just drag it down, it will automatically do it. And then you can also select these and drag them down too. So that's quite nice. So as you can see, I have all of these I haven't done the arrows yet, but I also have like pi and stuff, which is quite nice. These are some of my reference sheets. So for this pixel position, what Emerald Block did is he made this little program where all you have to do is you select the pixels and it automatically makes the number code. So if I took this code, entered it in here, it would automatically make the proper shapes, and then I just copy and paste the shapes into over here, and then this would decode them, and then it would display them properly. So that's very nice. It's all automated, and it was, in the end, I was doing like each letter only took like, or each symbol only took like 30 seconds, and this was all quick. Like at first, this was all manually done, and you can imagine how much time that took, figuring out each pixel position for each letter. But I'm very thankful that for all the formulas and this program over here that automated everything. So next you may be thinking, oh well, maybe you can make like a game on this, but sadly you can't. The reason is that each of these pixels are like they're addressed in sections, where each shape represents a section. So if you want to make like a game, you would actually have to hard code every single possible game state. Now, if for a simple game, that might be possible, but if you want to do like something with moving parts, that's not actually possible, because unless we unlock, okay, if virtual stackers and virtual painters existed, it would actually be possible, because you could just encode, you could have it automatically encode the shapes. You enter in, there's a position saved, it encodes it into shapes, and then the shapes are entered into the display, and it would actually display the game. But sadly, right now, there are no virtual stackers or painters. But I hope to see those soon in the future. But that doesn't mean you can't do anything on this. You could still do an animation if you just program in, because animations, you don't actually need to like have things move. Like if each frame is pre-programmed, and so this is actually perfect for that, because you can just, each of these could represent a frame, and you could scroll through them quickly using something like this binary counter, where each frame is just it increases, it goes through each frame once, and then loops around. So you could actually have like an animation. Also, what I've done, I may have mentioned this earlier, but I have increased the tick rate. So for the animation, you could increase the tick rate so it's much more smoother, because actually I'll show you this now. Let's say right now it's 180 hertz, which is 90 ticks a second. But if I do like 30 hertz, actually I'll do 60 hertz because 30 is quite slow. 60 hertz is only 30 hertz or 30 ticks a second. So right now this entire thing is 3 times slower. Now I could, if I did something like this where I just removed part of the clock, right? It would cycle faster. But if you watch closely, each of these displays, well, it's not easy to see here, but okay, this clock is, 1 second, I need to do this. It's not easy to see, but if I slow down the tick rate more, you will see that the displays update in sequential order. Like, they don't update all at once. That's because each rotator also takes a tick. So the faster the tick rate, the faster this will update. But then you'd also need a bigger clock if you wanted to be the same speed, because this clock also updates faster because each NOT gate is 1 tick. So yeah, that's how you could do potential animations on it. If I just press F4, you could see my tick rate in the corner, it's 60 a second. I feel like that should be interesting. Well, yeah, so right now it's 60. But let's say I changed it to the fastest tick rate in the alpha. Right now the standalone fastest tick rate, or like hertz rate, is 500. Here it's only 240, because no one has a 500 hertz monitor. But you see how this is way faster, right? Look how fast this NOT clock is. It's like 10 times faster. But yeah, so games aren't possible, but you could do animations or something along that line, and that's quite cool. I may try to do that in the future. Well, that'll be all for this video. I hope you guys enjoyed. Currently, the alpha is under a lot of updates right now, and some of which can break logic. Like the update that conflicts now make all gates output empty, that can actually break systems. But also, because many new parts are being added, that's another reason. Like a virtual stacker could open up a lot of possibilities. So I'm just waiting for those things before I do any new projects. So that's the reason some of my things are under delay. But I hope you guys enjoyed the video. Subscribe if you want to, and I'll see you next time. Later.